What's up, everyone? So today we're going to be doing concurrency part 2. Friendship with sync mutexes has ended. New best friend is buffered channels. So what does that mean? All right, well, this is what it means. So let's get a file going here. Go mod init. There you go. Okay. So, what we're going to do is we're going to be still generating some UUIDs, but what we're going to be doing instead of using like a sync mutex of some kind, so that we have like some kind of data structure to dump things onto as they're generated concurrently, we're going to use a buffered channel. And I think it'll become very apparent very quickly why I actually really like buffered channels. And the question I try to ask myself, and I've had a few people ask me this question at work: why would you use a, say, buffered channel over like a sync mutex, and vice versa? And the answer that I always give them is that a sync mutex on a data structure, like some kind of array of whatever you want to call them, array slices, whatever, I don't care. If you want to have something to append to, right, then do you know if the data that you're going to be appending is of a certain size? So what does that mean? Well, I know, for example, that I'm going to make 1,000 database calls. Okay. Well, if you know that you're going to make 1,000 database calls, then you have a sort of limit. You have a sort of idea of exactly how much data you're going to be using. And if it's not going to overload your RAM, if we're not talking billions of things, depending on your server or whatever that you're using, then I would tell you use a buffer channel over a sync mutex. And I'm gonna show you why. So this is what we're going to do. So I'm actually going to shoehorn this into also showing you how to write a very basic test. This is one of the reasons I love procedural programming and how Go does its testing. I think it's just fantastic. So what we're going to do is we're still going to generate UUIDs, right? So we need to have some kind of function that generates a UUID. So we're going to do func gen UUID. That's going to take a wait group, right? Because we still need to sync between Go routines. So we're going to do a sync wait group, and then we're going to pass it a chan error, right? So what we also need here is a channel for our UUIDs that we generate, right? And so we can just call that like uchan. I would say let's convert them to strings, because why not? We don't need the entire object, just for the sake of simplicity. But remember, I mean, this could be the type of like UUID dot. I have to import it, so go import Google slash. What is it? Oh, it's GitHub. Github.com slash Google UID. Okay. So then we can say UUID dot, UUID, which is essentially this 128-bit or a 16-byte slice. We could do either one. I'm just going to call it string because that is easier and a little more expressive, and it doesn't convey the point that I'm trying to make. So to use the entire UID struct. Okay, so we imported UID. So now let's generate a UUID, right? So notice that there's no return type here, because technically I'm not returning anything, right? anything that's being returned is being returned via the channel, which is kind of cool. So first thing we have to do is defer the wait group, right? And then we can kind of get into the meat and potatoes of things. Let's just call this UUID, or ID. Error is equal to UUID.new random. Yeah, which returns a version 4 UUID, which is kind of like the standard nowadays, I suppose. And then we can check the error. So if error does not equal nil, I'm still getting used to my keyboard. And the curly brackets are kind of in a weird spot. But I'll talk about that in my review, which is forthcoming. Then just dump the error onto the channel and return. So it's kind of like a short circuit, essentially, right? We're short circuiting here. We don't have any kind of return statement or variable or whatever that we end up passing back. So just return, cancel everything, and then the defer wait group would get done. So, okay, but let's say that we have generated our ID properly. Then we would just pass that back onto the channel. And return. Dot. String. Now how cool is that? There's no need to call any kind of sync mutex or even create a data structure, right? We don't have to create anything like that. The mechanism of the channel, of a buffered channel, provides us that exact sort of mechanism. Now, the important thing to note here is that I don't care about order. If I cared about order, really you have no choice but to probably use a sync mutex, depending on your use case. Remember, I don't care about order, and I 100% know that the data structure that the buffered channel that I'm creating will completely fit in memory. It's really no problem. So you can really just kind of use it like a first in, first out queue if you really wanted to, which is kind of what we're going to be doing here. So let's just say the length, number of iterations that we want to do is like 1,000, right? So we would make a channel for errors, right? So we'd have chan error length of L. And then we would have U, which is a channel of string, also the length of L, right? And then we know the number of go routines we're going to have because we know the number of iterations that we're going to have. So we can do wait group dot add L. Now this is a paradigm that a lot of people will use. I'll show you a different way of doing it if this is kind of what you so desire. Oh yeah, well we have to make a wait group as well. Yeah. New sync dot wait group. Cool. So now we just have to tell it to go out and do things. 0 I is less than L, I plus plus. Oof, I don't like that. I like having that space there. And then we would just do go gen UUID. We would pass it the wait group. We'd pass it C, which is the error channel, and we'd pass it U, which is the string channel. So this is certainly one way that you could do it. You would then wait for you'd wait for the wait group to be all done. Instead of doing wait group.add here, where you just do the length, if you're a little more paranoid, you can just do wait group.add 1, and you can do that in the loop. Either one's fine. It depends on your preference. I don't know. Some people get a little uptight about that, but I really don't care. And so something to note, though, is that while we have created a buffer channel that does it can hold 1,000 things. It can hold 1,000 strings, right? although we've created the channel that has that memory reserved, that does not mean necessarily that that is its length. So when we call length on a buffered channel, we're essentially asking how many things are actually contained within here. So if I created this buffered channel of length of 1,000, right, but nothing gets dumped onto it, technically its length is 0. There's nothing there. We've just gone out and reserved the memory for it, but there's nothing in the memory. My Vim behavior has been really weird lately. I don't know what's going on with it. It's kind of annoying. Cool. And then we can just do like log.print length of UUID channel. And this will tell us whether or not we actually have length of U. Just use printf, kids. Printf is way better. Just use printf. So yeah, I mean that's kind of like the general idea, you know. So notice how like I don't have to use any of this tooling here. Like I don't have to use any of the mute lock or mute unlock or really none of that. I don't have to create like a data structure that has a sync mutex. Like I don't have to deal with any of that at all. This makes it really, like, I really love doing this. So I would tell you that if your data is bounded, you know the bounds of your data, what's being passed around, and you don't really care about the order. You just need to go out, go grab a bunch of stuff, percolate it all together, smash it somewhere, so then you can analyze it. Then just use a buffer channel. They're way better. So, yeah, let's write a test for this, huh? All right. So we're gonna do the main go. We're gonna import testing, and then we're going to do func testing runner. We pass it a pointer to a testing.t object, and then we do runner. Do go test. Oh, test runner. Yeah, test runner, not testing. Duh. Hey, go test. There you go. Length of the UUID channel. Boom. 1,000. So there you go. Don't use the sync mutex unless you have to. They're kind of clunky, and it's easy to create bottlenecks with them. Only unless you have unbounded data, you don't know how much data it's going to take, then yeah, I would probably say don't use a buffer channel, but there are ways around that pretty easily. Like you could perform some kind of check where you say, oh, hey, you know, are you starting to reach your limit? You can have a go routine, in which case, you know, does something with the data in there, then flushes it. You know, that's always an option as well. There's lots of different things that you can do. But then I would just tell you this design paradigm of just using buffer channels is sort of like a, I don't know, kind of a hacky, concurrent, safe data structure of unordered data. I mean, if you really needed like a map string interface of some kind, yeah, then definitely do a sync mutex, because that thing cares about it cares about order, and it cares about how things are organized, and it allows you very quick lookups. And there's a lot of things that you can do. Go lookups are completely concurrent safe. It's when you're modifying data or trying to copy data or whatever that you'll want to have some kind of safety mechanism involved where you're not sharing memory, and that's where a sync mutex comes in. But if you're just tossing things onto a slice just to get it done, and then you just want things to get done as fast as possible, yeah, just use buffer channel, man. All right, let's go concurrency part 2. I'm going to do a part 3 where we're going to do a really wild concurrent CSV parser. There's a lot going on in there. It's very interesting. And yeah, that'll probably be my next video. Thanks.